In this video we will look at combined stresses. So here if you see pure bending or only bending, so there is no shear stress. So here if you see, sigma b equation will be simply my by I, where m is a moment which we have applied on our beam, y is a maximum distance from the neutral axis to the edge fiber, and I is the inertia of cross section of the beam. So you know this my by I. So here if we place for cylindrical shape, if we get 32 m by pi d cube. So both these formula are valid, but this is particularly for a cylindrical rod. So 32 m by solid cylindrical rod, 32 m by pi d cube. And if you see pure torsion, then it is shear stress is equal to T r by J. So T is a torque we have applied, R is a radius of this cylindrical bar, and if we put a capital R, it will be at the edge, means it will be at the extreme-most fiber, and J is a polar moment of inertia of the cross section. So tau will be 16 T by pi d cube. So if we replace both these formulas, 16 T by pi d cube. So both these are shortcut for cylindrical bar. Sigma b is a bending moment which is generated, and tau is a shear stress. Sigma b is a shear bending stress which is generated, tau is a shear stress which is generated. Here m is a moment which we have applied, here T is a torque we have applied, and this D is the diameter of the rod. And if we see, if we apply bending load and torsion load, then there will be combined stresses generated, and to calculate that we have this formula where sigma maximum means principal stress 1, sigma 1. If we want to calculate, then we have to use these two formulas only. First we have to calculate sigma b and tau, and then we have to calculate sigma 1, which is sigma maximum principal stress, by sigma b divided by 2 plus under root of sigma b divided by 2 whole square plus tau, means this is the formula. And if we put minus, then we get sigma 2. So here maximum stress will be sigma 1, that's why I have put this formula. If we take a minus in between, then it will be sigma 2, which is minor principal stress. For maximum shear stress, we know this is the formula for shear stress, which is exactly the same. So under root of sigma b by 2 whole square plus tau square. So this is how we can find principal stresses in combined stresses. And if we see here in terms of moments, if we place both this formula in these equations, then we will get sigma 1 comma 2 will be, means here I have put plus minus both, that's why. So if we put in these two formulas, then we get 16 by pi d cube and m plus under root of m square plus t square. So if we replace this entire formula with m equivalent, so m equivalent if we take as half m plus under root of m square plus t square. So here moment and torque if we apply individually, and then if we apply together, then equivalent moment which will be generated will be this much. And if we replace in sigma 1 comma 2, then it will be 32 m equivalent divided by pi d cube, which is similarly as this formula. You see here m, here m equivalent. If we apply bending and torsion load, then we have to use m equivalent, which is calculated from this formula, and the formula will remain the same. This is for pure bending or only bending load, and this is for combined load. If we see for the shear stress, tau maximum we can calculate from this formula. If we put both this formula into tau max formula, then we get 16 by pi d cube under root of m square plus t square, and which will be equal to 16 t equivalent by pi d cube, because t equivalent is under root of m square plus t square. So this is t equivalent, which will be exactly same as this formula. Here t is a pure torsion, here it is t equivalent is a combined bending and torsion. So this is how we have to calculate combined stresses. This is very frequent question asked in various exams, specifically in GATE examination, and this is very basics of this combined stresses. So thank you for watching this video, and see you in the next video.